Why is it so fast?
Well,
or why is TypeScript so slow? Maybe is the...
I'm not an expert on why TypeScript is slow, but I think one of the reasons why ReScript, the compiler is so fast is because it doesn't attempt to model all of the dynamic stuff you can do in JavaScript. It really limits you to safe and statically introspectable types. And the OCaml compiler is very fast, and that's what the ReScript compiler is based on.
If you're watching this video, it's probably because you're a high-level TypeScript professional, and as a leader at your company, you're always looking around for new and better ways to do things. So ReScript offers that fresh perspective because although it's a different language, it does compile to TypeScript and JavaScript, and there's a lot of familiar touch points. Like you can use NPM modules, there's great support for TypeScript out of the box, and it has a lot of great stuff for JSX and React. After all, it was made by Jordan Walk, one of the creators of React. So even the things that feel different are things that are probably coming to JavaScript later. So there are things like do expressions and pipeline operators that have been in ReScript for years that one day you're going to find yourself in front of as a TypeScript developer. So when that day comes, do you want to be completely shocked and flailing around trying to figure out how to use these things? Or do you want to take a moment and look at a different ecosystem that has already had this stuff for a long time and see how they chose to make React apps and how to build applications using those tools and what the patterns are that they developed? So that's why we think it's useful to show this stuff. This is Michigan TypeScript. So it's not TypeScript in this video, but there's a lot of familiar stuff, and I think it's going to be useful to you as a high-level TypeScript engineer. So let us know what you think.
All right. Hello, everyone. Thanks for coming tonight. It's great to see everyone again. My name is Rob. My title is a staff software engineer at Autobooks. For those of you unfamiliar with that role, it's mostly attending meetings, and sometimes I get to write code. A lot of collaboration with our product group, working on planning out features and that sort of thing, and working with our QA team and product team and obviously engineering teams to actually deliver those. So we're going to do a little tour of ReScript tonight. ReScript is a compile time language that compiles into JavaScript, much like most of the languages you might be familiar with today. So except for people writing like jQuery or heaven forbid, vanilla JavaScript in a server rendered like PHP, ASP, JSP app, you're not going to write JavaScript. What I call userland JavaScript. So that means like the code that's running in the browser that users actually see. So if you're writing any kind of single page application, or these days we've got some server rendered frameworks using Babel, ESBuild, SWC, TypeScript compiler. The code you commit hopefully to Git on GitHub and that sort of thing, if you're lucky, that has zero relation to what your users are actually running. I see some skeptics in the audience already, but I'll show you. So this is a class. As you can see, we've got a new private member here, right? Just an example class. And I want to show you what actually looks like to your users. This is cleaned up a little bit. So this, if you're lucky enough to target like ES6 and you can actually target a class, it'll compile to a class. Otherwise, it'll target a prototype. This code is kind of interesting all by itself. So if you see this weak map thing, this is kind of cool. It actually stores all of the private member instance values inside the weak map using this of the class, so that when the class is garbage collected, all those private fields go away. So pretty interesting way to model private fields in browsers that don't actually support it. This is emitted from TSC, but Babel emits very similar code. So if you're using Babel or ESBuild, you're going to see something very similar to this. And then, how many people, like show of hands, how many people have actually seen this syntax here?
This guy.
Just Ian. Great. So you guys use like Webpack, something like that, roll up Vite nowadays. This is what Webpack does to your precious ES module. Ian's like smiling and laughing because he's got trauma, just like me. So every one of your modules actually gets turned into a function that gets executed when it is required. So this E parameter is actually the CommonJS exports. R, the last parameter, is the require function, which is like how we transpile import statements into requiring those modules and do code splitting. And then this T module is the actual exports, the ES exports of your file. So we've got this function add locale that gets added onto T, and then if T is undefined, it defines this ES module. This is just like a signal to the rest of the code how to import it and actually use the exports. So yeah, you can see here, this looks absolutely nothing like our nice ES modules and that are checked into Git. All right, so I'm just going to go through a little bit of prior art. We have a long history, programmers do, of never actually writing JavaScript that runs in the browser. So we've got, static HTML. We've got our server rendered template languages, PHP, later Hack because Facebook never wanted to migrate off PHP. We got sick of that, so then JavaScript templating languages were invented, like Handlebars and Mustache. And before that, people started writing this DHTML thing. If any of you heard of that, yes, it's great. DHTML was like this new era of, we can actually when the user loads the HTML, we can actually change it with this JavaScript thing. So then we started writing JavaScript actually kind of sucks, so let's make these templates. And then we've got these SPA frameworks that started to come onto the scene. You've got Knockout, Backbone, Ember, Vue, React. All this stuff started to come on the scene where we actually started to write a lot of JavaScript and loading that into the browser. But JSX isn't actually JavaScript that users execute. How many of you used React before 1.0? So at the very beginning, Facebook was absolutely adamant. It was very clear in the documentation in the introduction. You do not need to use this JSX thing to use React. You can just write functions, create element. And it's kind of an interesting story. Dimitri and I attended a Reason meetup and got to meet Jordan Walk, who's the inventor of React. And he did talk about how JSX was actually inspired by PHP, but he was like, well, let's get these JavaScript developers to write PHP in kind of this sneaky way. It's kind of a fun place, or a fun talk. So if the output is correct, and the user's application works, hopefully bug-free, what does the input language matter? We've got a couple different examples of languages that have compiled to JavaScript before. You got CoffeeScript, PureScript, which is like a Haskell-inspired functional programming language that compiles to JavaScript. Elm, another FP language. JSX. You got Vue, single function or single file components rather, where you've got the template, style, and JavaScript model all in the same file on disk, we'll say. And then more recently, you've got Svelte files. Solid is using JSX. Flow and TypeScript, obviously. We've got Dart, all this WASM stuff that I'm told any year now will actually be ready. So yeah, we've got a lot of examples of programmers not using the same JavaScript that their users run in the browser. All that's to say, I'm going to talk a little bit about TypeScript, but not a whole lot here. TypeScript is the big guy. I mean, the meetup's named after TypeScript. Flow has kind of lost a lot of ground in the open source community. And, my opinion here is TypeScript both goes too far and not far enough in its goals. The goal is for it to fully encompass how dynamically you can write JavaScript, and provide people who like to write dynamic JavaScript a way to have static types. That said, if you've programmed in vanilla ES5 without types, you might remember all these null checks anywhere, type of undefined, crazy stuff to try and prevent your coworkers from passing absolute garbage to the code you're writing. So TypeScript lets you eliminate some of these defensive checks in exchange for, I call it appeasing the compiler. So you have to write your code in kind of a specific way to get type narrowing to work properly sometimes. It seems like they're improving it all the time, so that's great. But in the past, you almost had to be just as defensive in TypeScript as you would with regular JavaScript. Or even you'd end up writing a lot more code just because I assigned a variable and it could have potentially changed by the time I used it in a callback. And although I do think I saw they actually fixed that in a recent minor release. So that's great. However, it's kind of a wart with TypeScript in that the more you try and use TypeScript, the slower it gets, and the more you have to restart the server in VS Code. There's a discussion on the Discord recently of how do you guys restart the server all the time? And that ends up being one of your favorite commands in the command palette, just because sometimes you just gotta restart it. So immutability. I mean, at one point TypeScript didn't have the read-only keyword, but it's gotten better. Read-only is pretty good, but my personal opinion is it should have been opt-out rather than opt-in. I understand why they did it, but to be truly safe here at runtime, you're going to need object.freeze, write something to deep freeze, use Immer. Immutable JS is still around, much to Dimitri's chagrin. For input-output validation, you need something like Zod or Typebox, Yup, AJV. You really need something at the edges of your program to validate. There's not garbage coming in and going to cause runtime errors elsewhere where we've promised the compiler it's a certain type. And it's made assumptions with that in mind. So functional programming, obviously stylistic preference, but JavaScript can be written in a functional way, but it's not as suited to it as some of the languages that are designed for it. So if you want some types, some helper types like an option or a result, you got to bring something in. You make your bundle bigger and you're shipping more code to users. So enter ReScript. The tagline from the website: a robustly typed language that compiles to efficient and human-readable JavaScript. I'll show you some examples at the end. It comes with a lightning-fast compiler toolchain that scales to any code base size. Let me poll you guys real quick. How long does your TypeScript build take in seconds? Is it longer than a minute? Longer than 2 minutes? Around 2 minutes? Okay. 5 seconds? Nice. Okay. So with ReScript, because it's a functional programming language, you don't need additional runtime libraries like Immer, TS pattern, or FPTS. Bring in a lot of these functional programming concepts and keep your runtime code immutable and type sound. So ReScript might be for you if TypeScript strict mode is not strict enough, or you install tsconfig/strictest. You frown upon any usage of any in pull requests and get into fights over that. You watched the Michigan TypeScript type challenges video and came to the conclusion science has gone too far. Or you decided to attend the talk today. So one thing to note here is that React JSX support is in the ReScript compiler. They're working on a generic JSX transform, kind of like the new JSX runtime import. So in the future, they're thinking like, well, they'll be able to support like solid or potentially Vue in the future. Not quite there yet, but React is kind of the de facto framework in the ReScript community. So another thing I really love about ReScript and have for quite some time now. You guys familiar with any of these proposals on the screen? No? Okay. Do expressions, I think, has been open for I don't want to say inaccurately. It's been open for multiple years, and doesn't seem like it's going anywhere. Same with pattern matching and pipe operator, which recently seems like they're having a lot of discussion over the exact syntax they want to introduce. And of course, Record and Tuple building in immutability into the actual JavaScript language. I think this was introduced a couple of years ago and unfortunately has not made it into the later stages. I'll show some examples here. ReScript has these already. You don't need to install any Babel plugins and then break your TypeScript's editor experience. It's kind of unfortunate that TypeScript named a dictionary a record because they're going to introduce an actual record, but so there's a couple of key differences with JavaScript. There are 0 import statements. Every single module in ReScript is uniquely named. You might think this is a little strange and constraining. In the couple of years, I think almost 4 years now, we've been using ReScript at Autobooks. It really hasn't been that big of a deal. Obviously, you can't do like /components /utils and kind of dump things in there anymore, but it makes you think a little bit more about what your public APIs for your modules are, and it's kind of nice. It could be a little bit of cope, but there's no var or const, so you don't have to deal with any kind of weird like lexical versus function scoping. Everything's just let, and let is immutable all the time. There's no arguments about, hey, you should use let or const or whatever. So you can just think of let in ReScript as the equivalent of const. And the string syntax is cleaned up a little bit. You can't use single quotes, but you can use regular string interpolation and double quotes. And then a little bit of an weird situation here with integers. Instead of the number type, you've got 32-bit integers and floats. And that's inherited from the OCaml type system. All right, so I'm going to show you a lot of syntax. So let me know when you get confused. So just like TypeScript, we can create structural types. We can just assemble random literal values. Those are this special syntax with the double quotes around the property keys. And you always access them with the index or property access because they're not a record, which I'll show you in a second. So this top part is the ReScript code, and this would be your equivalent TypeScript code. And one thing you'll note, just a side note, one thing you will notice is there's very few type annotations. The type inference in ReScript is incredible. And pretty much everyone I've taught ReScript or shown ReScript at work is like, well, they come from a TypeScript background. They're like, how could you possibly know? How could the compiler possibly know what the type of that is without me telling it? But it just knows. Like it's pretty magical. If you want to look it up later, it uses the Hindley-Milner type system, which is the same as OCaml. So this is the second best feature of ReScript. And if you're familiar with fat enums in Rust, you can kind of think of it like that. So we have this type here, this user type T. T is like the convention for the default type of a module. So instead of doing like type user equals, you can do it in a module and then type T and then access it with this user type T syntax here, or user.t. So here's a little adaptation of some code we have for authentication status. You can be authenticating, you could be anonymous for a couple different reasons, like you haven't attempted to log in yet, your session expired, you got a 401, and you're no longer authenticated, or you manually logged out. So I'm going to show you the TypeScript equivalent. Looks something like this. These are just tagged template unions, or tagged unions rather. And you can see like it's a lot more code you have to write. It's a lot more verbose. And this gets especially annoying when you have like very, very in-depth state machines, for example. That's why they created xstate, is because they wanted to not write this out manually. Any questions on the variants? Because it's gonna build. Yeah, I'll go back.
All right, so module user at the top.
Yep.
Module user at the top is showing there's a union with two members,
Yep.
regular and admin, and they can have a string as like a similar to what we're doing with anonymous and authenticated at the bottom. Or is it that they have an object with a name property and the name is a string?
How this compiles is like regular is the type or the kind, the discriminant in the discriminated union.
Oh, like the tag in the TypeScript template tag.
Exactly, the tag. It actually compiles to tag in all uppercase. And whatever in the brackets, or not the brackets, the parentheses, is data you can stick in that variant. So this is just an inline record. You could do another type, like I've shown here. Like anonymous carries in it data that is this anonymous reason type.
Okay, and that data is itself some other type, and you can kind of chain them up.
This is called a polymorphic variant. It compiles to a string. You can think of it broadly like a string union, but you can also put data in these payloads.
Why are there square brackets around the anonymous reason type?
So this is just how you declare a polymorphic variant.
Polymorphic variant.
That's what it's called.
Okay, I'm gonna have to think for a second.
So they're kind of similar to string unions. So if you had a type, I'm going to go to the TypeScript. So if you had this type, obviously these are just strings, right? And you can just put the strings anywhere. But if you had a different type that was a subset of anonymous reason, you could still put it in type anonymous, or this member of the authentication status. So that's kind of similar how the polymorphic variants work. Another great feature of ReScript that has been requested for a very long time in TypeScript is nominal types. So you can approximate this. This is the TypeScript on the right, by the way. You can approximate this with these branded types by anding a type with this brand property and making sure the brand value is a unique type. You can see here well, you can't actually see the compiler error, but if we have a function here that takes type A, and you can see these types have exactly the same structure, this causes a type error. And it's useful for a lot of reasons, like I don't know if any of you use GraphQL, but it's all runtime checked. So you can't provide any excess properties to input variables, for example. So if you had some type in the GraphQL schema that's the same shape as a variable, and you try and pass that without stripping out __ type name, you'll get a runtime type error. That was actually one of the big reasons why we started using ReScript, is because there isn't a way to detect the excess properties if you're just using types rather than literals and constructing the entire object at the time you're passing it to a function. Go ahead.
Okay, so I think there was like a spaceship or something that crashed because they mixed up metric and imperial. Does anyone know what I'm talking about?
Yeah, it's the European satellite, it's the Mars.
Oh, it was the Mars rover.
No, this was like a long time.
In the 90s, the Ariane 5 rocket.
Oh, okay. All right, that one.
For the video, there was the European Space Agency, a Mars rover.
So this is that problem is something that I feel like I encounter at work with TypeScript, where I want to make an alias for number and I want to call it meters, and I want to make another alias for number and I want to call it feet or whatever. And I want to make sure that a function that takes meters will not take feet. But because they're both alias to number, TypeScript looks at that situation and goes, oh, well, they're both numbers. It's all good. And the only way around it is to do this branding dance that you have here. So are you saying that in ReScript, that problem, it doesn't have that problem? They're like, I think that I know them as opaque types, but.
So yes and no. You can solve this in a different way with primitive types by hiding the actual implementation of a type. So you can declare the public interface as an opaque type. I'll show you some code. I don't have a slide for it. I'll show you some code at the end of the talk. Somebody remind me. So you can hide the implementation. So the module that holds all the functions you'd use to interact with that data would know under the hood it's an integer or a float or whatever type it is. But anything else, you can control how it's constructed. So you have to create a validated data type, and then it would prevent other code from just arbitrarily assembling a string and calling it this is meters or.
Okay, so the answer is yes and then some.
Yes, and then some. Great, and this is a key thing I like about TypeScript is you can enforce these kind of business rules into the actual type system, and utilize type-driven development to say, okay, this is a credit card, and to get a credit card object, I have to pass it a credit card number, I have to pass it an expiration month and year, a CVV, and there's something called the LUN algorithm. If you're not familiar with the credit card numbers, you can't put in any credit card number. It has to pass this LUN algorithm checksum, essentially. And then you can know if it doesn't pass that check right off the bat, it's not a valid credit card number. So you could do things like, give me a credit card number. Does it pass the algorithm? Is the expiration date not in the pass? Did we try and call an API and it returned like a valid, yeah, that wasn't a stolen credit card, for example. So you can do things like that. Another great benefit, I mentioned this earlier, these are record types, which you have to declare ahead of time. They're kind of like structs, if you're familiar with some other C-like languages. They're immutable by default, so you don't have to opt in to immutability. It's just there. But one of the great things about ReScript is it provides you a ton of escape hatches. So you can actually, if you want to, you can write code that's very similar to JavaScript. You can make properties mutable, and alter them at runtime and just kind of change them. So one thing to note here is that TypeScript also has read-only array, which is kind of handled separately. They've got their own it's not a namespace, it's types for the read-only array, so it won't let you do like mutations, for example, like push on a read-only array. We don't have that in the standard library quite yet, but you could implement it pretty trivially in userland. And this starts to get a little crazy. Nearly everything in ReScript is an expression. So if you know what the do expression proposal is, it's just if else in ReScript. So I could actually assign like let text equals this if else chain, and it would be the value here, one of these values here, according to the count, or according to which branch of the if else returns. And one thing you might notice, there's no like return here. This is just the last line in the expression is the return value. Well, here's the equivalent JavaScript proposal. You've got this do block, and then you can use a Babel plugin for this. It's not really gonna. I don't think you can really write production code because it's going to give you a syntax error in your editor, and it'll fail to parse with the TypeScript language server. So I don't think you can really do this in TypeScript. You could if you're just writing JavaScript and like JS.comments, for example, but I'm not really sure anyone would recommend doing this since it's only like a stage 2 proposal at the moment. So like I mentioned earlier, JSX is built into the compiler. It's almost identical to regular JSX. And one minor thing that's changed is instead of when you omit the value container, the brackets, instead of that prop being set to true, it's set to whatever variable is the same name. So we've got this let class name, and this h1 is going to have that class name. And one thing you might see here is this is a block, and I can just, it's this value. So this is a really cool way to organize your code. You may be used to creating like these little helper functions to assemble, like you've got a bunch of intermediate variables to make something readable. You can just open a block in ReScript, and whatever the last line is, that's the value of the block, and gets assigned to a variable.
What happens if class name was not declared with a let on the 4th line?
It would be a syntax error because there's nothing. There's no variable declared with that value.
Okay. So then the trade-off there is that if you do want to pass a Boolean like we're used to doing with JSX, you have to say equals curly bracket true curly bracket.
You'd have to do equals true, yeah. There's some leeway with the curly brackets for the values. You mostly need to use the curly brackets if it's like a compound expression, but for the most part, you don't need the curly brackets around JSX value. They're called JSX expression containers in the abstract.
So it'll be a Boolean true, not a string equaling true if you just say equals true, like h1.
Yeah, you would just do the Boolean literal true.
Okay, cool. Thanks.
So this is the best feature of ReScript is pattern matching. You may have seen TS pattern, or some people really like this idea of switching on true, and then you put a whole bunch of expressions in the case statements. It's kind of weird, but it approximates this. So you can, I have this variant here, animal, and this is just going to be a bunch of animals. and I switch on the value, this is kind of like a pretty straightforward switch, like switching on a string value, for example. But you can do things like switch on an array. So if I have exactly no values in the array, return silence. If I have 1, it's going to call the sound function, return that. If I have 2 dogs, exactly 2 dogs, it'll return this. If I have a cat and a bird or a fish in either order, the cat's going to eat that other animal. And then if I have exactly 2, it's going to return this. And this last one is a fall through. The value gets assigned to this temporary variable, and then I can access it in the block of the pattern, of the case in the pattern match. So you can go pretty deep in this, and you can put these cases nearly anywhere in the switch. So instead of doing like cat, bird, cat, fish, bird, cat, fish, cat, you can do cat, bird, or fish on the same expression. And the same works for objects, records too. So if you're matching on a record, you can pick out specific values. This is really useful. We use it for a ton of things, but one of the biggest use cases I can think of is taking in some user information and determining if they're eligible for certain enrollment flows in our application. So if you come in and you're missing an email, for example, we need to get your email for you to be able to sign up for the application. Or if you're the FI, your financial institution, your user information is associated with has certain features disabled. We'll say, no, you're not eligible for this enrollment flow. We'll put you on a different enrollment flow. And then there's things called your payment rails, which is like how the credit card payments are processed. And there's a couple different ways for those payments to be processed. So based on our agreements with each specific gateway, you might get a different experience. One more. So like I mentioned, you can pattern match on an object. So if I've got a record with this shape, this comma underscore is just ignore the rest of the properties in the object. It's optional by default, but you can enable it as like a warning so that in the future you don't get this default fall through being hit without a compiler error. You can say, oh, if I add a property later, make sure my pattern matching is completely exhaustive. And I won't actually run into like assert unreachable at runtime because I forgot to add a case. And one other thing you can do here is you can add these dynamic if to the pattern match. Pattern matching is based on literal values. So if I need to check if like a value is in between a certain range, you would do it in this kind of if statement. And this is just an expression too. So you can nest a switch in the if. It's a little verbose, but you can do it. Yeah. So this is the sort of thing that the pattern matching proposal would allow you to do, but it's a couple of years old now, so we don't have it yet, but ReScript does. And another thing ReScript has is the pipe operator. So this is if you're familiar with compose or flow or pipe, these kind of functions that take a variadic number of functions to call and then return a function that then applies those functions in order. That's what this is, this flow function. So we take a response. We get the headers, we get the content type header, do some string manipulation on it, and then if it's null or not null, if it's a none type, then we default to false. So one thing that's really nice is that this flow function is just that. It's a function. At runtime, it has to run, and it calls like reduce on the array of arguments. And it adds a non-zero overhead to your code. The pipe just calls the functions like in like a order you would have called of, like if you have nightmares of algebra, it's like f of g of x, right? It would just compile to that. So you don't have the overhead associated with reducing over all the functions and assembling and creating a whole bunch of intermediate functions in memory and calling them and so forth. So I do want to show you guys some code examples of how this code compiles. But does anyone have any questions?
I got one question. How was the learning curve for your team when you rolled this out? How quickly did folks pick this up?
It can depend. So we had people who are writing TypeScript, and the learning curve, there is a learning curve. It wasn't too bad, a couple months, I would say. But we've also had people come in who had not even any TypeScript experience, and they came in and really got up to speed quickly and really enjoyed it. It was kind of almost a benefit not having previous TypeScript experience, because you're used to writing code in a very specific way for the TypeScript compiler, right? So I want to say probably onboarded more than 5, less than 10 developers to this. We've got a kind of a small team. And with one exception, everyone has vastly preferred ReScript to TypeScript. And I've never had to push anyone, hey, why don't you write this in ReScript? Once they get over the initial hump, they're like, wow, I feel like, well, I guess I can only speak for myself, but I feel like I can express myself way better in this language. It can be very concise and expressive at the same time.
So the idea you said is that const is now lets, and there is no let anymore. So is the idea that we have to do everything as constants now? Or are there ways to define mutable, like variables?
So you do have there is an opt-out. There's something called a ref, which is, if you're familiar with a React ref, it's really just an object with contents defined as a mutable value. So you can create a ref. I think it's also commonly referred to as like a box type in other languages, where you just have something in the box, and then you can dereference the box to get the value at the end.
So there's ways around it, but I guess generally the idea is we want to...
Yeah, so one example that comes to mind really recently is, let's say you want to iterate over an array and grab all of the values that have the same key. So instead of iterating over it multiple times, you can do an array for each, assign refs as arrays, and just like grab them all at the end. So there are many escape hatches to mutable code, and you can even write just raw JavaScript in ReScript. So there's something called it's %raw, and then you can pass it a JavaScript string, and just, you can either call JavaScript function or just declare a value straight up.
Cool, thank you.
I think you had a, I don't know if we care about the ordering of.
It's incrementally adoptable though, too, right?
Yeah. So one thing that until semi-recently you couldn't do in TypeScript was this kind of depth-first approach to conversion, right? So let's say if you have a TypeScript code base and you want to turn on strict mode, well, if it's of any like normal or large size, it's a huge problem to just turn on strict mode to begin with. There is a plugin for TypeScript to like incrementally turn on strict mode, and you can like annotate the file and be like, okay, enable strict mode in this file. I don't recall the exact name, but it does exist. But you can do it incrementally, and that's exactly what we did. Is we kind of converted things, especially like the problem children of like, okay, this TypeScript code isn't the greatest. We get runtime bugs, and we just convert systems over incrementally.
Yeah, my question was going to kind of be, did you go for the easy things or the hard things? But I guess we did the hard. Or
What do you mean
both.
by like easy versus hard?
Types.
Because I can answer a couple of different ways.
I could see this like fixing some problems that like TypeScript kind of has a hole in.
Yeah.
But then at the same time, like that's kind of like uncharted waters in a weird way. So it's like, hey, how do I tackle something with something I never used before that I can't even get done with the tool I already got, you know? But then, so then I would do some easy things, but then I guess you kind of just like teeter-totters.
So I think if I'm grokking your question right, the way we went about it was it converted these, we'll call them subsystems, of things that were complicated state management, for example, or state machines, or creating a state machine. Things that were complex and needed a lot of TypeScript code and were very difficult to get exactly right without writing a ton of, endless if-else statements and unit tests to go along with that. So to answer your question, like ReScript really lends itself to modeling complex state machines. It's incredibly easy. Like you don't need XState to model like state transitions between different states. You can just write a reducer and iterate over or write expressions for all of the items in a variant, for example, and you create transitions to and from each state. It's kind of interesting. So I was demoing, when we were deciding to adopt ReScript, I was demoing it, doing live coding in front of the rest of the front-end team. And we had this problem child system of, we have essentially a bunch of forms. So if you want to be able to create an invoice in our system, you need a couple things. You need a customer to invoice. You need products. There's a couple settings associated with an invoice. So we had this system of like, you're creating an invoice, but you want to be able to then like, if I don't have a customer yet, I need a way to like go create that customer and come back. So we had a cache system where we load the temporary form values into memory, shift you onto a different form. User creates their customer, for example. We take that customer, insert it back into the form values, put you back on the form and pre-fill all the values. So that was previously implemented in like just local storage, and kind of the logic was spread all over the place. So I went through an exercise live coding, moving that system to ReScript, and kind of the development cycle is a little different. If you like the phrase shift left, you'll love ReScript, because you're not really like, I make some edits, I click save, I check the browser and so forth. It's a lot of like, I'm writing a ton of code, hitting save, and then it just works at the end. So I was demoing this, I read the whole system, showed it to my colleagues, and my coworker Josh was like, I don't believe this works. And it just worked flawlessly soon as the code compiled. There's no like, forgot to handle some kind of case here. You just pattern match over everything, wrote a big reducer, and handle all the cases. And the compiler tells you when you're done.
So my question was, when you first introduced this, you said it was functional, and when I saw that it has only like constant, that reminded me like Haskell and like immutability of variables. Are there other functional features that you think, help make the argument for using this? Like, I think maybe some of the things you're mentioning in this last discussion were maybe features of writing functionally.
Yeah, so good question. One of the things we're doing, so for like results, if you're familiar with the result, let's actually, let me end this and then start showing code here. So one of the things that I dislike about promises is that they throw out exceptions. So one thing you can do, this was one of the things I was going to show you guys. So I can call fetch. I can await the fetch in the switch. So now I'm pattern matching on the result of the promise. I can catch any exception that happens during the execution of the promise. So if I get a JavaScript error here, I can return this error type with a fetch error. If we don't know what kind of exception it was, I can raise an unknown error or return an error, unknown error. If the response wasn't okay, which is just like between 200 and 300 or less than 300, I can return an HTTP error with a response in it. If it's not a JSON response, because I don't deal with like text plain responses, I can say the content type was wrong. And if parsing the JSON in the response body failed, I can say we got a JSON parse error. But yeah, this is another cool feature of the pattern matching, which is I can catch exceptions in the pattern matching. And one thing, I'll show you the code it compiles to. Here's the example from before where I was saying it just compiles to f of g of x. And you can see here it's just calling a whole bunch of functions one after the other, piping them manually. So this is the code it compiles to. And this is probably kind of similar to something you'd write manually, where you await the fetch, it's in a try catch. This is like a special property in how ReScript compiles exceptions. It's not really what you'd write, but you can return the error tag in a result. If the response wasn't okay, return an error. If it's not a JSON response. So this is pretty similar to code you'd write normally. And in fact, I kind of wrote a TypeScript example here of what this would look like. I've got this response error type, which is a bunch of different kinds of errors we could encounter in the process of calling our API with the various data in them. And this is essentially what a result compiles to in ReScript. You've got this OK state and this error state, and you either have type T in data or type E in data, E being your error. So you can see the formatting is better, but very, very similar to what you would have written manually is what the ReScript compiler will output in most cases.
And my second question was, what's a WA?
Oh, raw, yes. Let me show you that.
Oh,
Raw, yep. So I can just insert JavaScript wherever I want. If I have some code I'm porting over, but it's already like unit tested, for example, I can just write straight up JavaScript in here. You do have to type annotate it, but you know, it's int. This is an int, it takes an int. And then I can call it.
I just started using TypeScript, so I kind of just have a TypeScript question.
Yep.
You said sometimes TypeScript forces you to code defensively or in a way that you don't want to. I have my own like things I'm thinking of. Can you just tell me a couple of things that you're talking about?
So if you're trying to parse an unknown type, you either need to write a type guard and check all the properties and promise to the compiler, yeah, it's actually that type, or you can do a type assertion and throw an error. So that's something you would probably do in TypeScript that you wouldn't actually do in ReScript. Because when I declare a type to be a record, for example, it's always going to be that type. And it's always going to have all of these properties and exactly only those properties. It's never going to have more or less. Oh, and you can do the optional properties as well, by the way.
Maybe you touched on it, but is there ever any issue when using like npm packages? Just because sometimes you might need to import TypeScript types. So,
yes. Are you familiar with d.ts or declaration.ts files? I don't know if any of you wrote TypeScript back in the day, but it was very common. You had to write those manually all the time. They wouldn't be in at types. I'd say ReScript is probably in a relatively similar period as the early days of TypeScript, where not all of the packages are going to be typed. So you can write bindings like this, external. Let's just say I want to do value. Do left pad? Yeah. Isn't that built into the?
No, the NPM.
Oh, okay, yeah. Is it left dash pad?
I think so.
Takes a string and an integer and returns a string. So if I'd call left pad. By the way, you can't, I think this is something you can configure in TypeScript to be an error. You have to use the return value of functions you call, but you can ignore them with this placeholder. This is a first class citizen in ReScript. It's not like a value underscore or a variable with the name underscore. It actually just throws away whatever that is. So I can do like,
When I say using that, like any other value in the statement of the switch, I thought like,
yeah,
is it a first class citizen? Like,
yes.
Would I have to find another thing for the dash?
No, you don't have to do like this and keep appending underscores to ignore things. Trying to open my, you can see some TypeScript errors. One thing I didn't hit on here, but it's kind of important. So res build, 0.03 seconds. So this is like the most optimal case you will ever get for TypeScript, where it's compiling like 5 files. So it's a fraction of the time, 1.21 seconds versus a couple milliseconds, so a couple microseconds. So we can see here how this compiles.
Why is it so fast?
Well,
or why is TypeScript so slow? Maybe is the
I'm not an expert on why TypeScript is slow, but I think one of the reasons why ReScript, the compiler is so fast, is because it doesn't attempt to model all of the dynamic stuff you can do in JavaScript. It really limits you to safe and statically introspectable types, and the OCaml compiler is very fast, and that's what the ReScript compiler is based on. So because it doesn't attempt to model all of the possible dynamic things that can happen with your crazy conditional mapped inferred types and your, what was that limit you were showing me the other day, Dimitri, where the recursion limit in the
Yeah, you can only
TypeScript
recurse
compiler?
100 times.
Yeah,
Game over after that.
yeah.
In types. There is a tail recursion
No,
optimization.
for the type resolution.
There is a tail recursion optimization. Well,
Why
I mean,
indeed?
their thinking is you shouldn't need in a type to have a type that recurses 100 times.
Why is it 100? Why isn't it like 16?
Why isn't it 0? Why doesn't it detect when it's recursive? Like when you
Because
Can I lower the number?
so the
It's not suitable.
question is why isn't the limit for type recursion 0? And the answer is because it's a feature of TypeScript. They want you to be able to model these recursive types that like could potentially exhaust themselves. So another thing I wanted to show you was just the compiled output of. So this is the example I was showing earlier of the if-else expressions just being expressions, and I will do the thing I'd said here. Let text equals. So this is a React element, and I can stick the React element in the button. I have auto formatting off for the record, but you can see. Or maybe it's not obvious. If you haven't looked at what your code looks like, if you're using the JSX runtime, it just compiles to a bunch of function calls, which is exactly the same in ReScript. So your output is pretty much exactly what would have been done anyway.
Do you have an example of what a test file would look like?
So I don't in this repo, but there are bindings to vtest and just out there. So they look mostly similar to the JavaScript test files.
But there's just support. Okay. Cool.
There's just support. There's a couple other, obviously there's a bunch of node testing frameworks out there. I think there's one even built into Node nowadays, right?
I'm a little out of
so
the
you
loop
could,
on Node, but yeah.
because they're just functions, right? You can write external bindings to them and use the node asserts, for example, if you wanted to.
Okay, cool.
But yeah, there's a React, there's a couple of different, we call them bindings to regular JavaScript packages. So like React testing library, hook testing library, Jest, that sort of thing.
That dovetails nicely into a question I wanted to ask. So I think you answered it, but I'm a little slow. So from TypeScript to ReScript. Also, we didn't talk about, it was ReasonML, but now it's ReScript, and then there was Buckles. Maybe you can answer that later. I'm confused.
So maybe it's, if you're not familiar with the history, it can probably be better to just ignore the words ReasonML and BuckleScript. What happened shortly after Dimitri and I attended ReasonConf in Chicago a couple years ago is the community split. And ReasonML is another thing invented by Jordan Walk. ReasonML is an alternative syntax for OCaml. And OCaml is just a different compile language. And ReasonML used what is now known as the ReScript compiler, but was previously known as BuckleScript to compile from Reason to JavaScript. If that's confusing, just ignore everything.
I'm totally lost. Yeah, no idea.
If that's confusing, just ignore everything I said and search for ReScript if you're interested in ReScript.
All right, so ReScript then, to go from TypeScript to ReScript, there's not an automatic step where you can just ingest .d.ts files. You have to write those like interfaces to go between. Is that right?
Are you talking about the packages? Like
yeah, you
NPM
showed us
packages?
that the left pad example that you showed us.
Yep.
Okay, so there's nothing that exists to do that for you, or is it a philosophical problem, or is it a practical problem if someone just hasn't done it yet? In other words, is there a
Of
deep
automating writing the bindings?
yeah? Is there a deep reason why it won't ever work, in that I can just grab any TypeScript file and it'll be working?
So I'm thinking like, how would we write this, right? Like, could you just parse it and then express it in the other language in the same rules, looking at like the AST that you got from the one language to the other? But like, look at that first example you did where there were the two types, and you were saying that like, it's either this type or that type. But in TypeScript, it's really just looking at two different strings. And like, I guess like our inches versus metric example, right? Like the way that'd be defined in TypeScript doesn't necessarily exist in ReasonScript. So you couldn't necessarily run a converter from one to the other.
Yes, but also no. So this is a section of the docs. Can you guys see this? Okay. It's called gentype. And you can add this @gentype annotation to ReScript types, and it will automatically create a TypeScript analog based on the compiled JavaScript format of that type for you to be able to use in TypeScript.
Wait, you're wiggling out. That was my next question, and that's super cool. But I really want to understand, if I have an existing large TypeScript code base and I want to introduce ReScript, am I going to be stuck rewriting all of my TypeScript that's already in my project in ReScript, or can I just directly import those files, those TypeScript files, and kind of use them?
Yes, you can directly import the generated TypeScript types and code to use from TypeScript.
How does that work?
So this is a compiler plugin. Let me see if I can set this up really quick and demonstrate. I think you have to do...
That's okay. We don't need to see it in the full flesh. I'm just making sure I understand. So, okay, then you can go both directions pretty easily then, it sounds like.
Yes, there's a couple of caveats. This is improving all the time, especially with ReScript 11. You can customize the actual runtime representation of the variants, for example, to make them look more like what you would have written in TypeScript. So this is called customizable variants. So you saw here, or maybe not that exact thing, in the variants here. Go to res. You can see it's got like this tag, all uppercase, JavaScript representation. So one thing you can do is rename the tag using this @tag annotation, and you can customize how the variants compile. You can see here this state variable compiles to this JavaScript output.
Wow, that's really cool. So it looks like they went through a lot of trouble to make sure that what boops out the other end doesn't smell that bad.
Yep.
Cool.
And to more directly answer a question about if I've got a big TypeScript code base, do I need to rewrite it? The answer is no. Autobooks still has a ton of TypeScript code. It doesn't really churn that much because we don't touch those features that much, and it works, so why go and rewrite it arbitrarily if we've got a small team with limited resources? So we've got a ton of TypeScript code, and they can interop fairly well.
So we touched a little bit on some of the ecosystem tooling out there, like testing. What is the situation like for sort of the rest of the ecosystem? I'm thinking like styling, for instance, or, I think I saw you do like an import of a CSS file in one of these files. Like, what is the story around sort of the rest of what you get with like a modern bundler?
So the answer is like, it's pretty much exactly the same as the JavaScript ecosystem. So if you want to use CS and JS and you want to define types for however that CSS and JS is being declared, you can do that. Or if you want to import CSS, that's not like, it's not really JavaScript or like a concern of ReScript, right? So you can bail out and be like, And then this is just handled by your bundler. So, I mean, you can just bail out and write some JavaScript in here. You could do if import.meta.env, you know?
Okay, so the sort of the compile chain here is you'd run your ReScript through its compiler first. It creates ES modules and JavaScript, and you take the result of that
And you would
that would then
bundle it.
also have
Yeah.
these import CSS and send it through Vite or whatever, right?
Yep, exactly. Oh, it's not running. You do need to have the compiler running. Yeah, and you see it just dumps the JavaScript in there. It has this extra semicolon just to make sure like you didn't leave one out accidentally. But yeah.
How about auto formatting, like prettier? Does it do something like that itself?
So ReScript, the compiler has its own like built-in formatter that is quite opinionated. There's no knobs to turn. There's no like options whatsoever. If you look at ReScript code from just random open source ReScript library, it looks exactly the same as any other ReScript code. You can just run it through the ReScript formatter. Any other snide comments of, you know? All right, well, thanks everyone.